3D Geo. Let's explore how to solve this pentahedron problem. Okay, so we have the base of a pentahedron below 13 by 8 rectangle. Okay, that's this. And we have its lateral faces are these isosceles triangles. And we have these isosceles trapezoids over here with bases 7 and 13. And we're trying to find the volume of this thing. Okay, so first things first, we have this as 7, we have this as 13. We want to figure out what is this kind of extra part. This extra part is nothing but 3, right? This is just going to be 3. Similarly, we have that this extra part is also going to be just 3. And even though they look very asymmetric here, as you might imagine, that's just because of the diagram, the way it's oriented. But these parts are equal here. And we have that this is kind of like this part 7. So these parts are equal, 3. And that's because it's an isosceles trapezoid. These are equal, so it's symmetric. Okay, so 3, 8, and let's see if we can try and maybe divide up our this weird region into some shapes that we actually know how to find the volume of individually. So what I'm going to do here is I should maybe use dotted for that one. Let's use dotted. The amazing dotted line feature. It's really cool. Okay, so we have got 3 here. Let's say that's 3. Okay. We have this is 3. Let's say that's 3, right? And then let's try to do the same thing on the other side. So let's just say we have, let's say we have that this part over here is 3. So we can divide up this region. We can imagine we draw another line here, right? I'm trying to help visualize as best as possible. Let's see, imagine here. Now notice this region over here. It's just kind of like a pyramid. It's actually a pyramid, right? Because we have this pointy on top, we have this base on the bottom, right? So we have this volume of this kind of right pyramid, and we have the identical thing over here, right? We have the same exact thing here. This is going to be a pyramid with base area 24, right? 1/3 base area 24, and the height we still don't know. We don't know what this height is, but let's see if we can visualize it. So let's say we have our height. Let's say it's like something like that, right? We know it's going to be like a 90-degree angle here. How are we going to find what this height is? Okay, so we know this is 3. We know this is 13, 8. We know this is an isosceles triangle, so we in fact have that this part, that's 4. So we can solve for this green length. Or you know what might be even easier way to think about this? Imagine, notice here. This over here is 5. Why? This is 3, right? I know this is a little bit tricky to actually visualize right triangles in 3D because the angles don't look right because of your angle. But imagine we kind of tilt this on this side. This part and this length is also 3, and this is a right angle. So then we have that this is equal to, this green segment over here is equal to 5. So take a look here. And then this is also a right angle. Like imagine, right? This is on a plane, and then we have something on top, right? This is just going to be a right angle. So we have 5. This is going to be 12, 13 because of Pythag triplets. So we have our height, this purple dotted line over here, is just 12 by 5, 12, 13 triangles. So we have this volume. That's just 8 times 12, 96. So that's the volume of one of these kind of pyramids on the left and the right. So we have 192, right? Because times 2. Now what's the volume of this middle region over here? Well, notice this thingy is 8, right? We know this height is 12, right? So imagine now that here's kind of the idea here. In this pyramid, we have this as the base. For the other part, for the prism, we want to have this as the base. Because then we have this height of 7, and we can kind of see that this is a prism shape. So what's the volume of this prism? Let's just highlight it just to make it absolutely clear. We have this prism over here with these two as their bases. And this is one of our heights, and that's one of our heights. This is our prism. The volume of this prism is just the base area times the height. The base area over here, that's 12 times 8, 1/2 times 12 times 8, right? This is equal to 8. So 1/2, 12, 8. The base area is 48. So the volume is base area 48 times the height, which is nothing but 7. So 7 and 48 times 7, and a quick way to do this is 7 7 times 50, 350, minus 7 times 2, 14, 336. We have our total volume is 192, 2 times this, plus 336, giving us 528. And that's it. It was that simple. Really, the only hard part about this problem was visualizing that this was a pyramid and this was a prism. And we kind of have to think, okay, this pyramid has a base area here. This prism has a base area here. So we kind of have to mentally rotate it in our minds. But the actual calculation was really easy. So yeah, it was just about the trickery of figuring out the 3D-ness. And I hope you learned something from this video. Thanks for watching.